A core requirement of the original GSM specification was international roaming, a feature not available in first-generation mobile systems. Roaming enables a subscriber to use their handset and SIM card directly in another country on a different network without having to change terminals nor SIM cards. A number of conditions have to be satisfied for roaming to operate correctly. First, the handset must be able to transmit and receive on the frequencies used by the GSM network in the visiting country. Second, a roaming agreement must exist between the subscriber's home operator and the operator to which the subscriber will connect to in the visiting country. Finally, the roaming function must be activated on the handset, a feature which is sometimes determined by the tariff plan. This diagram gives a simplified overview of roaming. When the mobile device is turned on or is transferred via handover to a new network, the new visited network recognizes that the handset is not registered as one of its own subscribers, and then attempts to identify the home network from the IMSI, which is stored on the SIM card. If there is no roaming agreement between the two networks, the visited network denies service. If roaming, however, is allowed, the visited network contacts the home network HLR using the SS7 signaling system and copies the subscriber's profile from the home network HLR to the visited network VLR. Subsequently, the visited network begins to maintain a temporary subscriber record for the device in the VLR. Likewise, the home network HLR updates its information to record the location of the subscriber on the visited network, so that any information sent to that device can be routed correctly. In the case of incoming calls to a roaming mobile subscriber, in other words, mobile terminator calls during roaming, the process is as follows. The call is routed to the home network GMSC using the subscriber's MSISDN number. The home network HLR records show that the subscriber is currently roaming. The HLR also holds information regarding the subscriber's exact location, which is continuously updated each time a mobile station moves between base stations. The home network queries the visiting VLR, which in turn assigns an MSRN number to the roaming subscriber. Once the incoming call is routed and established, the MSRN is released back into the pool of numbers and can be reused by other mobile stations entering that area. Billing in GSM networks is a complicated process, thus it requires an operation and support subsystem. Here we present a brief overview of billing in GSM during roaming. First, the serving MSC of the visiting network generates billing records for all mobile stations on its network, including roaming terminals. These billing records are referred to as call detailed records, or CDRs. Every day, the visited network sends the CDR files to a data clearinghouse, which sorts the CDR records according to the home network ID, which is contained in the subscriber's IMSI number. Subsequently, the data clearinghouse collates the CDRs according to the home network ID, rates them according to an interoperator tariff, and sends them off to the relevant parties. At the end of that month, the different home networks settle the wholesale cost of the roaming subscribers' usage on the corresponding visited networks, according to the rated CDRs they have received through data clearing. Payment is made through a financial clearinghouse. This financial clearinghouse collates all the payments from the home networks and delivers them to the correct visited network. The retail charge for all traffic generated by a roaming subscriber whilst they were roaming on the visited network will appear on their bill issued by their home network. This normally appears on the subscriber's bill as roaming charges. To conclude this section on GSM, it is worth discussing another key service handled by the connection management layer, namely the sort message service. This service allows text messages to be exchanged between mobile stations via a sort message service center, or SMSC. Key functions and characteristics of the SMS service include the following. First, store and forward. During this operation, if a message cannot be delivered to its target, then it is stored in the SMSC until the delivery is successful or the message timeout value is exceeded. Second, out-of-band signaling. The SS7 signaling network places an upper limit on the size of the messages. However, it does enable messages to be transmitted even when the voice and data channels are in use or are congested. Third, guaranteed delivery. As implied above, a failed message is resent until delivery is successful or until it has timed out. In addition, the network supports delivery reports for the messages that were sent. All data in an SMS message is transferred in a single packet. This packet comprises a header part and a user data part. The header identifies the type of message, for example, whether it is a normal text message, a ringtone, or a logo. The remaining parts of the message are used for control purposes to provide instructions to the SMS sender, a SIM card, the handset, and eventually the air interface. Such parts include the originator and destination address, the protocol identifier and data coding scheme, as well as the user data and the user data length.